Today we'll be looking at the standard normal distribution from Stats Year 2, Topic 3. So let's get right into it. So normally for our normal distribution, we have our mean and our variance. And so on our y-axis, this can take our values can be essentially any values we can want them to be, and they all follow this bell-shaped curve. Now so for the standard normal distribution, our mean is always 0, and on the y-axis each value represents a standard deviation. So here we are 1 standard deviation away from the mean, here we are -1 standard deviation away from the mean. So in order to get from this normal distribution to standard normal distribution, what we can do is that we can essentially code the values of x. So we can say that z is equal to x minus the mean over the standard deviation, which allows us to standardize the data. This is useful when we want to compare sets of data that have different values on the y-axis, and also for large sets of data. So to better understand this, let's look at two graphs. So if we know that the standard deviation here is 10, we can do z is equal to 50 minus 60, our mean, over 10, which is -1. So our 50 would take on the value of -1 on the standard normal distribution. And this tells us, and so this equation here tells us how many standard deviations any value of x here is away from the mean. So what we're doing is we're finding the difference between our mean and our value of x, and we're dividing that by the standard deviation to find how many standard deviations it is away from the mean. And we can also note that the area is the same for both graphs, which is useful when we want to use the inverse function. So whatever area you have here, you'll plug that into your calculator here, and you'll often have to put in the area, what tail it is. Essentially it's the data all on the left, all on the right, and our standard deviation, which is always going to be 1, and our mean, which is always going to be 0. So we can also write the probability z is less than a as phi of a, where phi is the cumulative distribution function, meaning it always has to be less than or equal to a for any value of a. Okay, you can't have, say, phi. So if we wanted to find the area here in terms of phi, we couldn't just do phi of 1.6, because that would just simply give us the entire area from here to here. It wouldn't give us this area here. So there are two ways we can go about trying to find the area for this graph here. Okay, either we could do 1 minus phi of 1.6, okay, which would essentially give us this, so that this is phi of 1.6, okay, and if we do 1 minus that, we get the area here. Or if we notice that this graph is actually symmetrical, and that if this is 0, then here we have minus 1.6, right? So if we did the area, if we did phi of minus 1.6, that will give us the same area as phi of 1.6. So either we can use a symmetry of the graph, or we can just do 1 minus phi of 1.6. But the important thing is the data must always be to the left for phi. Okay, so this is what you need to know for a standard normal distribution. We'll come back to this at the end of the video, but for now, let's look at an exam style question from Edexcel. Okay, so a length of adult Dachshunds is normally distributed with mean mu and standard deviation sigma. Given that 20% have less than 16 inches and 10% have length greater than 18 inches, find mu and sigma. Okay, so for this is going to be our normal distribution graph, which has probability x is less than 16 as 0.2 and probability x is greater than 18 as 0.1. So we know that the area here is 0.2, area here is 0.1. And we can see from here that our areas are the same. So that's going to be 0.2, this is going to be 0.1, mean 0, and our standard deviation 1. So what's different is that on our y-axis, that's going to be different. So here we're going to have the value of z1, and here we're going to have the value of z2. Now, because we have two unknowns, mu and sigma, this means that we're going to have to use simultaneous equations in order to find their values. So first, what we can do is we can say that z1 is equal to 16 minus mu over sigma, and then z2 equals to 18 minus mu over sigma. Now, what we can do on our calculators, right, is we can use the inverse function. So if we go onto the CG50, we go on to normal distribution, then we go to inverse normal distribution. We can enter in the area of 0.2, and because all the data is on the left, our tail, okay, is going to be left. And then for this one, because all data is on the right, our tail is going to be right. Okay, so now that we've done that, we can say that z1 is equal to minus 0.8416212, and then z2 is equal to 1.28155157. Okay, so now we know what z1 is and what z2 is. Right, so now we can equate this back here. So we can say that minus 0.84 equals to 16 minus mu over sigma, and that 1.28 is equal to 18 minus mu over sigma. We can then rewrite this, so we can have minus 0.84 sigma equals to 16 minus mu, and that 1.28 equals to 18 minus mu. We then add mu to both sides, so 0.84 mu plus 0.84 sigma plus mu equals to 16, and it's going to be same here. Equals to 18. We then can use a simultaneous equation function on our calculator, which means that we get a standard deviation of 0.942 and a mean of 16.792. Okay, so what we can see is that our mean, this is between our values of 16 and 18. So we can, although I know this answer is right, just to, when we're in the exam situation, if we have two values here, we can check. So the mean is between 16 and 18, so that's probably right. Our standard deviation, so we can just plug it back in and then try and find if we get a value of 0.2 into our normal cumulative distribution. And then for our z1 and z2, if z1 is to the left of the mean, this means it takes on a negative value, because if you look here, all these values take on negative values. And then if z2 is above the mean, this means it always takes on positive values, so it's always positive. And these values are going to be between minus 3 and 3, because this is where most, if not all all the data we care about for our standard deviation distribution, standard distribution. This is all the data we care about. It's usually between 3 standard distributions from the mean. So it should be between 0 and 3, which we can see it is. And then going back to this, just to finish off, so our equation of the line for the normal distribution is 1 over root 2 pi e to the power of minus z squared over 2. And we actually can't integrate this function of the line, which means what our phi is, this is just an approximation of the area under the line. Okay, either we use our exact z values, or we approximate. So we never truly get a definite area under the curve for this. And if you want to know the reasoning behind this, then there are many resources online. I would recommend I would recommend 3 Blue 1 Brown, a popular maths video channel that covers complex topics like these. So that's it for today's video. I hope you found it useful, and if you did, don't forget to like, comment, share, and thank you for watching.